if I want to take these two as my system, if I want to take these two as my system, then there is an external force by the spring on the block. So is linear momentum of the system conserved? It is not conserved. The answer is as plain and simple as that. Linear momentum of the system for the entire motion is not conserved. It is not conserved. Okay. But there is a catch here. Why it is not conserved? Because spring force acts. There is a spring force. Why there is a spring force? Because spring is compressed. Why it is compressed? Because block is moving. Why the block is moving? Because of collision. So after collision, block starts to move, and once it starts to move, then spring is compressed, and then there is force, and then momentum is not conserved. But that happens after collision. The block acquires velocity after collision, not before that. And this force appears, the spring force appears once the block acquires velocity, not before that. I hope you are able to follow everything that I am saying, or I am saying it to myself. Am I saying all of these things to myself? I am saying it to you. It is for you. It is for you, okay? It is for you to understand. It is for you to follow. Do not let me speak to myself. Okay? So follow the logic. The spring force appears only after the spring is compressed, but the spring will be compressed only when the block starts to move. And the block starts to move only after collision. Okay, so first collision happens. The block acquires some velocity. After that, spring force appears. That means during collision, I can conserve momentum. During collision, but after collision, I cannot conserve it. Okay, that means just before collision and just after collision, I can conserve momentum. But I cannot do it for the entire motion.